And next, we go into item 8, the agenda, integrated microbial source tracking and hydrometerologic controls in fecal indicator bacteria and upper Charlotte Harbour Canal systems, presented by Richard Whitman of Harbour. And the purpose of this is to share results from a study implementing a volunteer-driven microbial source tracking and water quality monitoring and analysis program of canal openings in Charlotte Harbour. A connection to the CCMP relates to Water Quality Improvement Priority Action 1, supporting a comprehensive and coordinated water quality monitoring and assessment strategy. And with that, Dr. Whitman, over to you.
Thank you, Betty. This is your microbiology session this morning. First, we're going to do peptides. Now we're going to do FIBs. And many of you, and I don't know most of you, but if you don't mind, I'll introduce myself. But I am now the chief science officer for Harb. I'm the co-founder. We founded this Jennifer about 3 years ago, and we've really taken off. We've got all kinds of activities in the 3 mission areas, and that's service, education, and research. And so I moved from CEO now to chief science officer, and now as last week, I'm the emeritus chief science officer, spending more time with my kids and my scholastic and popular articles that I worked on. And I'm going to be summarizing the scholastic work that we did, I would say, it's in draft for submission. And you're one of the first to see it. I made a couple of national presentations, but this month, first local one. So with that, we started this project. We're sitting around trying to figure out how we could employ water quality across Charlotte County, working with a team from Florida. And Brandon Moody comes up and says, "Hey, Punta Gorda, PGI is now TMDL." And I said, "Yes," okay, because that meant we had a target, we had a regulatory guidance, and we had support of Punta Gorda and Charlotte County. And Baron and I put together this program, and this is part of what you saw. I've been studying FIB for about 35 years. I was chief scientist for the National Park Service in Southern Lake, Michigan. And my superintendent says, "We're in the Chicago Tribune. I got a problem. I don't know anything about bacteria, but I'm going to help you out." Okay, it's just another organism, right? And so we started on this project with a group of friends. Team Punta Gorda provided administrative support. Charlotte County provided funds and guidance, again, from the water quality management people. NOAA supplied the analytical support. These are all friends that I've had from working relationships over the years that I've worked at USGA for 30 years. The stuff, mostly fresh water though. And they did the MSD marker analysis. University of Miami provided academic and predictive support. In Georgia, we're doing metagenomics, the community analysis, trying to figure out, superimpose not only the markers, but the organism, the community of microorganisms, including K-herpes, and how it might fit in. So when you're looking at, say, a canal that's intertidal, exchanging Calusa and Peace River, you want to know what communities is most similar to reinforce what you have for markers and so forth. I'm getting all kinds of stuff, not even prokaryotes. And Rotary Club gave us some money and City Punta Gorda allowed us access. All those are data that I collected and consolidated largely from the water atlas. So thank you very much, CHND. Could not have done it without you. Oh, back 15 years ago, I started to summarize my research, and basically I was looking for sources of E. coli because that's the organism that you use in fresh water. And we were challenging EPA and CDC wherever we could, developing this toolbox that you guys now use for TML analysis and so tracking and so forth. And we were like one of the first to call this from the sand on beaches. That's what I have on recreational water quality. Because that's where EPA was with the Beach Act. Sources were largely from sand, some came from birds, some from animals that came from upstream. It's still beneath the litter. It survives in the winter E. coli growth. Whoa, that was a new paradigm challenge, right? That E. coli and nitric oxide grow in nature. That threw EPA for a loop. Gave me the name the E. coli killer because that doesn't work with regulatory organisms. And I learned, right, being someone that used to do water quality, that E. coli is different. It's got an ecology of its own. And my lack of microbiology actually led me to ask questions that normal microbiologists would never ask. Like, does it grow outside in arid environments? And yes, it grows and it persists. And so now that's become part of it. So this was a whole lecture and that I gave with the Great Lakes Beach Association. Just this, it was part of a paper I did on a watershed wide, called then a beach shed. It's not a watershed, because that's what we wanted. And kind of coined the term. So anyway, that's just a summary of my life up to that point. Well, so when the TMDL requirements were triggered by excess concentrations of nitric oxide, we jumped on it. And first thing I did was I'd already been studying for 10 years ago, the Charlie Park Beach complex, okay? Because they were having issues there. It was the only beach that was close by that was challenging enough. So, but we took the Charlotte Park Beach, we had Sunrise. This is mostly FIB data. And I wanted to see not only the two areas of Jameson Circle, Ponce de Leon, and Alligator Creek, but I want to see as much of the East Wall as I can. I still do want to do the Harb, look at the balance of the bacteria. A budget, that's all it is. It's just it's like a nutrient budget, and E. coli or nitric oxide FIB. So we went down Burns Creek, the Burnskill Road, Ponce, Alligator Creek, Peace River, Sunrise Canal, and the beaches. Okay, not so much on the beaches for the TMDL, but it doesn't be so. Okay, and then we develop an internal monitor because FDP doesn't have the jurisdictions to go up the canals. County goes up the canals, some of the like Cape Coral goes into the canal, but the state federal don't belong to that, right? And so we developed internal and we monitored that for 18 months. And the money ran out, and then we're on hold there. Yeah. But these data are not included in this analysis because it's too small a data. 18 months was not enough. We were interrupted by like 4 hurricanes. We lost our sampling sites and so on. So the idea was to challenge not challenge, but to compare our data with the state's data. They came out Monday of the month, and we came out 1.5 hours later. And there really is no significant difference. There's no significant difference in the data that they generate, that we generate. The only problem is that our data is one taken a little later. Okay, and that's very important. Okay, temporal variation is very important in bacteria. And the other thing is they lost many of their stations. And so I say there's no difference, part of it's lack of statistical power to differentiate the two apparent PPS. So I looked at these are our constitutions. Anything a lot. And I traced them. I just did the same thing, Molly, with Brandon's data, right? But you guys have way too many stations to show here. Okay, but Brandon made the mistake of giving me that data, and that's going to keep me busy for another 6 months. Alligator First Road Gilchrist, Peter Gilchrist, Poncedelia. What do you see? You see some common variation. What's that tell you? There's something basin-wide sort of going on. What's going on basin-wide, right? Hydrometeorological events, force impacts. Oh, duh. Okay, now it gets pretty interesting. Okay, let's find out what those forcing factors are. Okay. So this is stuff I did for Charlotte about 11 years ago when I first came down there and first met Jennifer. And I was looking, what kind of correlates do I have for enteric oxide concentrations at Port Charlotte Beach? And I took the Arcadia gauging station, knew a little bit about that being out in USGS, and I put them in the bins, okay? I said, okay, these are the big bins. These are big, heavy summer rainfall. Okay, I don't show it to you in the season. All we have to do actually over here. And this is E. coli. Whoa, look at that. Look at that. It rained. Okay, I wrote an article on waterline. Rain rules Charlotte Harbor. Not just when I'm talking about this, not just talking about FIB, we're talking about nutrients too. Okay, and color and humidity and CO, M and so forth. Okay, so don't think of this as isolates because if you look at a Pearson correlation coefficient, they're all going up and down together. Tides, rain, summer, so it's all hydraulic. Okay, and so now this red line, okay, is the this area here. You see these events, okay. And this is mean, okay, and this is mean enteric oxide. It's not unusual. See, here's that line, that cutoff, and see that gets exceeded very much. And those are the exceedances that are causing your PMDL triggers. Okay? So it's a summer rain event. Okay, so that's where we start to focus in. Well, if you really want to know the system, let's take your cardiovascular system. You want to know how it works. You stress it, okay? The rains tell you so much, just like a stress test, what the system can handle, where things are coming from. And so we had one thing we never had in the federal government was an opportunity to get to the scene on our own, day or night, whether it's lightning or not, okay, whether it was congressional funding or not. When we had Hurricane Katrina, it took me 6 weeks to get to New Orleans to do a bacteria assessment because we had to have permission from Washington to be mobilized. We saw our tropical storm Debbie coming, and we said, we're going to get there and move it. We don't have any auto samples, we don't have any much, but we have volunteers. We have volunteers that are willing to get out there in the middle of a storm and sample throughout that storm. And that's what we did. We said, okay, it's coming. We take our samples, we get our pre-storm, we can get post-storm, and the during storm. So this data is not common, okay? Because what people do during a hurricane, they leave, right? We stay, okay? So you can see what happened to the bacteria. Here's the pre-storm on August the 2nd, levels of E. coli. I mean, enteric oxide. And this is the green accumulation, which I think will, I guess, 7 inches, right? Here's the clearing of it. You see it goes up, it goes up, it goes up, the almost 10 to the clear, push it, and then it drops, okay? As the rains stop, okay? And we have the pollutions, the aftermath, and the surge subsides, okay? Yeah, right? But we'll see there is also a hangover effect here. Look at all this organic, this tidal creek by the Gilchrist Park. Look at all that. That's oxygen demand. Okay, something's going to happen. That's going to push nutrients. That's going to eventually push your algae and so forth. Okay, you have huge just perturbation. It's worthwhile saying. Okay, just to give it more visual effect, here's pre-storm loading of organic debris and detritus and so forth, and post-storm. Okay, and I'm thinking these are DNA samples. That's how you get DNA on the filter, you send it off for analysis. Okay, now I went to marine school a couple of years, but that was a long way. I am going on.
There should be a front and a back arrow.
Yeah, I know.
Okay, we'll get you back there.
You're going the right way. It's just, yeah.
No, yeah.
Okay.
Yeah, it is being wonky. All right.
Can you help me?
Yeah.
Yep. Is that the correct?
Okay. So, hey, honestly, I haven't been in estuaries in 40 years, okay? But this steady, you guys have a very complex system, okay? This is a hell of a lot different than streams and lakes, okay? With these things you call tides, okay?
Pesky.
But it's also healthy a lot. And one thing that I learned, and you probably already know, is there's a really great correlation between salinity and color. Okay, I mean, must have made a mistake here, okay, because you don't usually see these kind of regressions, do you? But you did. So and it turned out, well, I could use either one of those parameters for predicting the one mad, okay, and trying to overcome that correlation with monster. But okay, next. So I plotted color, for instance, and against the color, against color. And I'm using this against the criteria of 130 by the state of Florida. And I saw two clusters that were, even though, okay, yeah, I got a correlation of 0.6, that's okay. That's appreciate that. But I also saw two clusters here, one above here, the one below. I think that's interesting. Let's go ahead and see how I can model it. Next. And I did it first with salinity, which turned out to be a little crisper color, but there's a lot of noise. Okay. More noise than salinity. And it's like I could have used ammonia, I could have used PKN, I could have used phosphorus, right? But I would have gotten a good model, but it wouldn't be as crisp. And the other thing I wanted was something litmus thing I could just take and put in the water and tell me whether the bacteria were high or low. Okay, and salinity and color are those kinds of parameters that will test kit that you can use, live use and so forth. That's one of the things I do. So I use this as precision proof for bacteria. And what I found was that if you take the whole log normal intercoxide and you sort it out through person cartridges, you will find out that a salinity of 21.39, right, is the cutoff for high. So if it's less, okay, if it's less than 2021, right, you can anticipate a mean of 1.7. Okay, I put over here for translation, right, for 1.7. Okay, 1.7 is high. This one is the phrase is high enough to put out a warning. Okay, by EPA, Department of Health. Okay, it is not enough to close the beach. Okay, some places, live in Canada, they will close the beach. Okay, but not in America. You close the beach. And but at 1.84, you do in 2.11, you start okay, so under that, so hey, so what I was looking for is this right here. How accurate am I? Now, I can tell you that about 7, according to these data, and we need more data, that we can predict it within 70% of the accuracy, which is good enough for me if I had the stock that I could predict that 70% might be built in there, right? And it's a lot better than what we use now. It's 0. You know what it was yesterday, we were showing today. Okay, there's no relationship whatsoever unless you've had many different rains over a period of time, so that you got your good strong loading. So then I went to color, okay, and what I found in color was we have that a low color, we have low bacteria, and high color, we have high bacteria, and it's very CPU of 58. Then you'll have explosion. Okay. So it's what we used to say in the great place. If it looks dirty, it probably is dirty. Okay. You don't need a weatherman to know which way the wind blows, right? As Bob Dylan says. Okay. But in the middle, can't tell. Okay. Free. Wishy-washy. It's not differentiated. That's only what about 20% of cases. Okay. Let me clarify one thing real clearly. This is not Captiva. This is Captiva Street on the border, in the middle of the Rim Canal. You got equal distance between this Captiva Court. Okay, I should have used another name. Between Alligator and Ponce-de-Leon. So I want to get right in the middle, and this is where we did our tropical storm heading sampling. Okay, so we saw some of the counts, the MPN cultural counts. These are the DNA counts. Okay, the markers. So let's see here. Let's go to human first. Orange. Here's pre, okay, and then the storm comes in. Here's your storm window right here, 3rd and 4th, and it pops up. Okay, now stays up. Okay, so these human markers in those canal systems, such as canal systems, the toe went up very big. They didn't go up very much. Okay, we're only talking to 100, 500 copies that ED and not really terrible, but there is a source, and those source persisted during the storm and after the storm, which tells me that we have an infrastructural problem, that something failed. Okay, with the septic field or package plants or something that's still there, and there's still a trace. Okay, there's still smoke. Okay, and of course we didn't sample it enough, long enough to find out if it came back down. Okay. Let me go then to, oh, did you do that or?
No, I didn't do that.
Yeah. Let's do dogs, okay, 'cause I really thought dogs were gonna get it, okay, because every neighbor has dog, and all these lawns, all this surface, surface areas and so forth. And they didn't, okay? Well, we really got a couple of kids, but really, just, they were local, and then came back and up and down. I'm not quite sure, but, so much for that hypothesis. Green, okay? Birds. No one tells me. It's the birds, right? And that's what we told, Bird Davis. Tell me it's not the birds. I got Audubon Society, all over places. No, it's the birds. And it's the birds most of the time, not most of the time, but a lot of the time. But what's amazing to me about the DNA of is how consistent it didn't care whether it was storm, based, winter. They're up there all the time doing whatever. They're in the wetlands, they're on the wire, they're on golf courses, and they're shitting, and they're closing down our beaches and are causing millions of dollars, right? Of government investments, right? And make me do all these things. So thank you very much. God. So that's fine. Okay, so I mean, we're looking at 10 to the 5th, okay, versus 10 to the 2nd. Okay. The blue line is intracoxide, the digital eDNA intracoxide. Now, I'm very pleased to see that the digital, because the word always is digital ED, that quantitative PCR. Dead ones as well as live ones. Okay, so sometimes it can give you artifacts. But our intracoxide 1A are digital and our cultural back very, very nice. And you see the same thing I showed you. Okay, and before without mistakes high. But remember when you look at this is long scale to the point, then the third, up, then over 10 to the fourth, then it's back up at 10 to the fourth. So it's up there. But remember, get in a line. Okay, so I was interested in the relationship between the birds and the digital DNA, and look at that point. This is the correlation coefficient. It's 0.93. Okay, that's again very supportive of this bird story. The human marker is at 183, and intracoxide is 0.26. For the R, since R squared 0.97% of the variation next month. Yeah. But it's there, but it's very small. So everything so far is fairly consistent. Next, please. Okay, this is the DNA, down a depositional zone, just up. I don't know if you know this. If you don't, you come into Ponce de Leon, go over the rim canal somewhere. You see these big old huge ponds, right? Sediment ponds. And we took 11 sediment samples from them by kayak. Went through 2 transit, a couple of different ponds. And so we want to know the sediments are saying the same thing. Because believe it or not, there's a lot of bacteria in that sediment and intracoxide. So anytime you have this, and you can't really tell sometimes whether it's tidal flush or whether it's a storm or whether it's just a bloom or whether it's just, effluent, because it's all there together or runoff. So we want to, but those settling ponds are telling you the history, okay, of what's gone on, not just the last day or two, but weeks and months and years. And so, and the sediment so far done is the same story, right? Dogs low, humans are 10 to 2, birds who 10 to the 4th, 10.5, right? And her toxic side is right there in the middle, okay? So there we go. And very much the seven's telling the same thing of water is. I don't have the community analysis that had instrument problems with Savannah, Georgia, at the water school there. So, and that, that's the whole story. Okay. This has something to do with the. Wait, no, it's not bacteria, right? But it is, it's all about. Okay. So this is the spreads. This has Hurricane Eileen. By now, we have in situ monitors in the water and you see the tracing from pre-storm, right? You can see the storm comes in here. Right in there. This is pre-storm now. DO wasn't anything to that's in blue. And there's nothing bright about it, but that's what DO is in the summer, that time of year. It's 4, 5, 6, which is no upsetting. That's not, you know, really. Then we have the storm. You see the DO come down, storm ends, the DO is still coming down as the oxygen demand of all that debris is sitting there. It goes to zero. Yes, we had this kill here, right? It persisted. Look at this, okay? 15, 17, on to 2 weeks. And we had in Hurricane Debbie, not only Frisco, but when it's still debatable, we had all these horseshoe crabs. Okay. And there was no oxygen, there was no oxygen. And we find it, we tried both several sides of the wire the effect. So we were able to see that anaerobic pulse and with very slow recovery. This is short term. Okay, this is only 15 to 17. And then we saw the oxygen demand stay flat. So come back up a little bit and pop. 10 days later, we really saw the demand from. Okay. So all the litter, all the detritus takes a little while, right, to get established and get it. Okay, future. We had the chat. Jennifer mentioned that this Charlotte Harb ambassador training, and they got trained on analysis, sampling and analysis of FIB. Currently, we can't. I guess Water Keepers does it now. HOH does it, and but we can't. We had a lot of them. I really love the way the state does the sample. They all do the sample at the same time. 7 o'clock bacteria and 9 o'clock bacteria, very different bacteria. Okay, heat breeze picks up, the sun comes up, the UV starts to kill the bacteria, and then so they spread out. Here are all the sample sites they had. These samples from Port Charlotte, okay, all the way down to Cape Coral. And so the students analyzed, we had 20 samples. This is the local physician. This guy teaches at the University of Cincinnati. He's a neurophysiologist. So, and everybody knows Rose was teaching. And these are the kinds of numbers we got. I think that these two numbers, and these three numbers, Brian's going to use for human marker analysis. And so this is a great way to do a synoptic study. Okay, so as part of your walkthrough in HTML, one of the ways to do it is get a bunch of volunteers from HOH, so you can find them and send them out sampling all at the same time throughout that water bodies. and then bring it back and see where your hot spots are. And then go into those hot spots, see where they're coming from. Okay. And take some, while you're out there, take a bunch of water quality. So there I am. Okay. Like I said, you find helps with there. So get that out.
I've got a few. I found this quite interesting. If memory serves me correctly, we had to do some studies maybe 20 years ago at Siesta Key and the sediment in our pipes because we were having beach closures. And we also found that it was mainly bird, if I remember right, it was mainly bird source bacteria. So my question is that the case everywhere? Like, have you noticed, or do you know, like you mentioned Savannah or places like that, like maybe the Carolinas? Do you think that's the case there too?
Yeah, probably. Okay, I'm not, I mean, I'm not gonna say, that it's always the birds, okay? You certainly have failing septic fields, I mean, and operative, and you have overflows from sewages and so forth. But most of your running waters in the temperate US and the subtropical have a pretty big bird load, okay? And differentiate, and that's why all this molecular marker has been phenomenal. So, these pipes were
Stormwater
stormwater.
pipes.
Yeah.
So it's like sediments and stuff to get in the stormwater pipes. We had a lot of beach closures. We started doing some studies up there. This is like 20 years ago, if I remember right, but.
Well, I never pointed out that the just because bird doesn't mean it's farms. There's a lot of pathogens. It's like 5 times higher if you're human sources. And pipes have a tendency to keep the bacteria alive. Just think of the pipe as an enteron in your intestines. There's no line, there's good flow, bacteria nutrients, they need flowing nutrients. Also, people like there's plenty of surface area to test, and you will actually find with the sometimes that the FIB is higher at the source than it is higher at the end of the pipe than it is at the beginning, because then there's more sloping on and there is actual growth and degrowth. The temperatures are.
Then the other thing I was going to just kind of mention, I found it interesting in the beginning how rainfall dependent a lot of all this stuff is. And so I guess I worked with, I was tasked like, once again, like 20 some years ago, set up an oyster monitoring program and worked with Florida Gulf Coast University and Mo to come up with the way we did it. So we monitored % live oysters. And it was, the goal was to help guide management decisions in the watershed and things like that. But really, after 20 plus years of collecting data, it is like mainly rainfall dependent.
Yeah.
Wet years, we have less % live oysters. Dry years skyrockets back up % live, and that's been pretty consistent for my whole whatever.
And so I think we really need to rethink the HTML and the TMBL and the sanitary surveys and take into account the natural sources and the fiscal forcing factors.
So I'd like to weigh in on that as someone who spent most of my prior career to this job working in water policy and regulation, that the TMDL does take into account natural background loading. That's why the load isn't zero, like it understands, there's a load reduction, but that's only from anthropogenic sources. And that's teased out when you go forward into developing a TMDL and a BMAP, where they're able to isolate what proportion of loading is coming from each source and then how much needs to be reduced. So, certainly birds have declined, obviously, greatly over time. And so, the bird load is the natural background load, and it's actually supportive of the ecology of the system to have bird life. And we're not even at the bird life we used to naturally have. And our systems were not as impaired when there were more birds than they are now when there's less birds. So I don't want the takeaway to be that the birds are the issue, because really, like, in my opinion, like, that is fully addressed and accounted for in the regulatory process and policy. We have a lot of impaired waters in this area, of which none that I'm aware of are going forward for TMDL or BMAP development. So, you know, there is no hammer here that's causing anyone to invest a dime into reducing nutrients that are coming from birds. So I definitely want to make sure that's clearly understood. If anything, going forward in those regulatory processes, there are steps where that is further investigated, and that proportionality, what is that natural background load, would be quantified and would be removed from the nutrient reduction allocations, because that nutrient reduction allocations are only assigned to anthropogenic sources. So it's really built, the whole system is built in a way to account for natural loads and to make sure that no one is having to invest any funds into reducing natural loads.
And I would only add a couple of things to that. One is, we didn't have DNA markers back then, not very long ago, okay? Probably, now, and so it was very difficult to say, it was an inference. We didn't have the actual. The other thing is the birds, depending on what kind of birds they are, what the causation is. Up where I come from, and still some marine beaches is the gulls and the geese, okay? And it's the habitats like the gulls we had in southern Lake Michigan, mostly were coming from landfills, the ring-billed gulls and herons, okay? So they would cause a problem, and so managed birds became part of keeping our beaches open. I don't think that's particularly the case in the places that I.
Yeah.
Okay.
Yeah, I will say
really know about
the
farmlands and stuff.
the basin water quality fact sheets that we produce do show the impairments and for which parameters. And those impairments are based around the water quality standards, which are generally rules of thumb. They're not meant to be water body specific. Not until you move beyond the impairment status does the state invest sometimes resources in developing a TMDL, which is in fact water body specific. So then you get a much more refined, standard for that water body through the TMDL than you would just through a generic water body standard that's just tied to the designated use of that water body. So a lot of times we're dealing with that very first step in that whole process where they're just using the standards, for nutrients, for bacteria, for dissolved oxygen, and saying, is this routinely exceeding that or not, or meeting that or not? And if it's not, then it's impaired. And that's really only the first step. A lot of people think, oh my God, that means we're going to have to do something. It's not usually that step that something, necessarily you have to go into developing the TMDL. The TMDL does then take that deeper dive to do all the things you're talking about. And then the TMDL goes into point source discharge permits immediately. And then that's all that happens at the TMDL stage, and not until you go to a BMAP stage of developing a basin management action plan, which is again not happening often when there is a TMDL. But only in the BMAP would you go into non-point source and try to isolate what each anthropogenic non-point source pollutant discharger is responsible for reducing, and trying to address that side of the pollutant loading equation. So I just want to make sure people understand there's all these safeguards at every step to account for a lot of these things. They're thought of, they're understood, and they're definitely addressed before. Only at the end of the BMAP stage do you get any requirements that would then be transferred to a city or a county to try to meet. So by that point, you have definitely, figured out, okay, we're gonna take all the natural sources, how much is that? We're taking that out right off the top. And then who else, is it ag? Is it stormwater? Is it wastewater? They go through allocating percent reductions to each of those. And basically we end up with something that's extremely well supported and robust at the end of before anyone has to make investments.
I'd like to just add on the siesta key thing, it didn't matter whether it was bird bacteria or not. Our goal is to stop beach closures for bacteria. So we did invest in a big system up there that has, we have like UV and all this, and a stormwater collection system and a pump. We put a pipe in that takes it way offshore and all that to try to decrease beach closures and all that. So we did invest a lot of money. It didn't matter whether it's birds or whatever.
And was that the
bacteria.
local government?
Yes.
Yeah, so I mean, it's certainly a local government above and beyond, but I'm just talking about the state regulatory process of, like, if a local government wants to go above and beyond for its own objectives, it's certainly always able to do so. But I just want to make sure that people understand that you.
Yeah, my intention is never. Awesome. Ups and downs and sequences, mechanisms.
I think from a CHNP perspective, we understand that there are natural contributing factors to like red tide or bacteria, but we definitely want to focus in on what are the things we can control and influence. And those are those anthropogenic sources. And so like the CCNP kind of is outlining, like, let's do what we can to control the unnatural sources. And then, at the end of the day, if that doesn't restore the natural balance of flora and fauna, then, we'll have to address it. But right now, we haven't really effectively done that. So that's like really the first step.
I got one question before we wrap this one up. The predictive, you spoke about the predictive ability of salinity and color and so forth on against those thresholds for swimming. At the moment, do the beach closure advisories, are they based on actual collected data, or are they based on a modeled? They're based on collected data.
The managers are allowed to use predictive models if they can show it meets the same kinds of rigorous school does, and predictive models are utilized. There's a whole bunch of models. We models for like Michigan published in the newspapers. We still did the bacteria, the culturable side, but no, I don't know. Well, there are some states like New Jersey. If it rains, they close the beach. Okay, first. And there in Ohio, you specifically can see your feet at B depth, close the beach. So there are those kinds of rules of thumb that are used, but not, I wouldn't call them regulatory. But there are allowances by EPA to use other methods, or even to keep the beach open. You can show, if you say like these are not human, this is law, not quite sore, to allow beaches to stay open.
And one other quick question with the birds, I noticed it actually drops off after the storm as well. The bird markers.
Right.
Is that because of defoliation of the trees, or why is that dropping?
I don't know why the water is still on. I think you're on top of the population. Answer that one.
Yeah, cool. All right, I think that's it. Thank you very much.